Hello guys. So this is our second project, and in this project we are going to solve a use case using multiple linear regression. Now whenever I say multiple linear regression, that basically means I will have at least more than one independent features. Okay. So for this, I will just increase the complexity more when compared to the previous one. And the data set that we are going to use is something called as economic underscore index.csv. And again, this particular data set I have actually prepared by seeing some of the stats information. I'm not taken the complete data set, but at least 25 records from there. And we'll understand how we can implement multiple linear regression on this particular data set. Let me talk more about this particular data set. This data set is all about index price. Now, first of all, we'll try to understand what is index price. Okay. So what is index price? Now here you'll be able to see index price is a measure of relative price changes consisting of a series of number arranged so that a comparison within the value for any two periods. So to calculate this index price, and government uses this specific index price, over here we require two important things, that is interest rate of the bank and the unemployment rate. And based on this, by applying some formula, we basically calculate the index price. Now I have all these details based on month, right? All 12 months, you can see 2 years data is there. That is the reason you can actually find out 24 records. So 12 years data is there. Now we need to create a model which will be taking these two important features, that is interest rate and unemployment rate, and it should be able to give us the predicted output index underscore price. And that is what we are going to do. Why we say this as a multiple linear regression? Because here I specifically have two features. Okay. In the previous example, we just had one independent feature and one output feature, but here we have two independent features and one output feature. Okay. So let's go ahead and let's try to solve this problem. Now, first of all, as usual, what I'm actually going to do over here is that import pandas as PD. So same step, import matplotlib.pyplot as plt, then import numpy as np, because this all things has been already done. So I'm just going to quickly complete this so that I hope everybody knows how to do this. Now we will try to read the data set. So here I'm just taking this specific data set and I'll say df underscore index. Okay. And I'm just going to read this data set. Let's say I'm going to write read underscore CSV, and here I'm basically going to take, pd dot read underscore CSV. And here I'm going to basically take economic index dot CSV, right? Now, if I write df underscore index dot head, so I basically have my 2 years data. Very simple. Now, over here, the first thing that you will be able to see, right? You have this extra column that is getting created. So first of all, I will just drop this column. In order to drop this unnecessary column, let's drop unnecessary column. And here unnecessary column basically means I can also consider year and month, because I don't require this, right? Based on interest rate and employment rate, I need to be able to predict the index price. And whatever year or whatever month, if these values are given, we should be able to predict the index underscore price. Okay. So let's drop unnecessary columns. So here, first of all, I'll use df.drop, and always make sure that whenever you're trying to drop a column, you have to use one important parameter. Okay. So let me just go ahead and write df underscore index dot drop, and let me press shift tab. Here you just need to provide the labels and your axis value. You can also provide index or columns. Okay. So here, first of all, let me columns. So columns here, I can definitely provide something like, let's say in the list, it will be unnamed, or I'll just copy the same thing. Okay. And here I will add axis is equal to 1. So if I execute this here, you can see that this unnamed column will get dropped, right? And this will be the remaining data that I'll have. But I also have to drop year and month. So what I'll do, in this list, I will add year, and I will also add my month column. So once I do this, here you'll be able to see that it is getting deleted. It's working perfectly fine. Now, when you're sure about this, then there will be one more feature inside this, one more, that will be in place is equal to, right? So here, when you do in place is equal to true, that basically means you are actually dropping the column now, right? So, and once you drop the column, it will get updated in df underscore index. That is the main importance of in place underscore true. That basically means within this particular data set, you're dropping it and you're updating it. So now if I go ahead and execute this, this will be my df underscore index dot head. Now here you can see I have two features, independent features and one dependent feature. Perfect. Now, first of all, let's go and see whether we have any null value. So in order to check the null value, I will write df.isNull.sum. This is the common code to basically find out check null values. Okay. And right now I'm not taking it, but as we go ahead, we'll have some amazing problem statements. So let me go ahead and write it as df underscore index, because that is the habit, right? Most of the time we will try to write df. Now, after checking the null value here, you can see you don't have any null values. So obviously this particular data set, what I'm actually first going to do is that let's do some visualization. Okay. And this visualization that I specifically do, I use a library which is called as import cbon as SNS. And then here I'm just going to write SNS dot for that specific library function that I'm going to use is something called as pair plot. And if I give my df value here, automatically, sorry, it should be df underscore index. Again, I'm making this mistake again and again. Not a problem. Now, if I probably go and see this df underscore index, here is what things you are actually getting. You can basically see with respect to index price and interest rate, you can see some linear relationship is there. With respect to index rate, you can see inverse relationship is there, right? So again, if you check employment rate and interest rate, again here you are getting an inverse relationship. So if I probably go ahead and write df underscore index dot corr, so here what we are going to get is that we are going to get some negative values also, because this interest rate and employment rate, here you are having a negative correlation. Similarly, with respect to this index price and unemployment rate, here you are having a negative correlation. But if I see with respect to interest rate and index price, you have a positive correlation. So that basically means as the interest rate is increasing, your index price will keep on increasing. If your unemployment rate is increasing, your index price will be decreasing. Now we are going to use this two specific feature and try to implement some amazing, we'll basically create a machine learning algorithm using multiple linear regression. Okay. Now let's go ahead and let me first of all make some cells. I'd also like to make sure that I visualize these data points, right? Unemployment rate, interest rate properly, right? So let's go ahead and visualize this more closely. Visualize the data points more closely. Okay. So here I'm going to just take df underscore index, or I can also use plt.scatter plot. And here I will be using df of, let's say I will go from interest underscore rate, along with, I really also want to see the correlation between okay, here one more thing that we saw, right? What is the correlation between unemployment and interest rate? So obviously here you can see that it is an inverse one. And with respect to index price also, it is inverse one. So obviously both these features will play an important role in predicting the output. Okay. So now if I go ahead and probably see the scattered plot, df of interest rate and df of unemployment rate. Okay. So let's say unemployment underscore rate. Okay. And here I will probably use a color. Let's say COLOR is equal to red points. Okay. So here it will be R. Now if I probably execute it, so here you can see df underscore index. Again, same mistake, but I don't want to edit this part now because it can happen with you. Okay. So here obviously you can see that it is having an inverse relationship. Okay. So obviously here I can also do plt dot x label, and here I'm just going to write it as interest rate ELT.y label. Here I'm going to basically have unemployment rate. Okay. And once I execute it, here you'll be able to see it. Obviously, inverse relationship, the same diagram we have got it in a bigger one. Okay. Now, we do it for the next one, that is interest rate and index price. Obviously, you'll get a positive correlation. Fine. This is perfectly fine. Now let's go ahead and implement. First of all, what I'm going to do is that get my independent and dependent feature, right? And when I get my independent and dependent features, first of all, I'll write X is equal to df underscore index. I know what all column I basically want. So I'm just going to write my column name. So first one is interest rate. Let's see. This will be my interest rate. And this, the next column will basically be my unemployment rate. Okay. I can also do in this particular way. Let me show you and another way how you can basically do it. Okay. So df underscore index, I can also use iloc. Okay. And here iloc first parameter says take all the rows, comma, from all the rows, just remove the minus last row. And here you'll be able to get your X value. That basically means from all the features, just from all these features that you have, just remove the last feature, because index underscore price is your output feature. And this is obviously a continuous value. So regression problem we are trying to solve. Okay. Similarly, for the Y variable, here you can write df underscore index dot iloc, and here colon, comma, colon, or -1. I'm just saying that take the last column and put it in the Y value. Okay. So this two way also you can basically do it. Okay. So once I execute it, here you'll be able to see X. So let's go and see X dot head. Here you see your interest rate and unemployment rate. And similarly, if you probably go and see Y, here you'll be also able to see. Anyhow, this will give you an tuple. So I'll not suggest you to go and display your data like that. Here is perfect. Now the next step is very simple. We will do the train test split as already explained. Train test split. Okay. From sklearn dot model selection, I'm just going to import train test split. Okay. And then you have x train, comma, x test, comma, y train, comma, y underscore test. Okay. And then here I'm just going to use my train test split. I'm just getting bored a little bit. So let me go ahead and copy some of the code from here. So this is my train test split. Let's say I'm doing 25%. So I'm just going to paste it over here. Okay. So here I've given XY test size 0.25 and random state underscore 42. So once I execute it, here you will be able to see your X train, Y train and all, right? Now guys, I'm also going to introduce you all to a new kind of plot in Seaborn, which will basically be very, very helpful when you are actually working with this kind of data. Now, let me go ahead and show it to you. First of all, let me import Seaborn, okay, as SNS. Now in Seaborn, you have something called as REG plot, okay? And if you probably want to see this plot, I'll just execute this, okay? And let me copy this one over here and let me just write Shift Tab. Now here in this particular plot, this plot is all about this plot. It plots data and a linear regression model fit. Okay. So let's say if I'm using df of let's say in my x-axis, I'm just going to put one of the feature, which is like interest rate. And my another feature over here will be df of the index price. Okay. So if I just try to plot this, okay, so it should be df underscore index. Okay, my mistake again, not a problem. You should do mistakes. Okay, df underscore index. So once you plot this here, you'll be able to see with respect to this kind of data points, this is the regression line that will get created. So this gives you an amazing idea that yes, the errors that probably you're going to get is quite less. Okay. Similarly, let's say that I'm going to copy this same thing and I'm just going to plot this along with the interest rate, let's say the interest rate and the unemployment rate. So if I probably write unemployment rate and if I plot it here also, you'll be able to see that, yeah, you are able to get an amazing regression line within this particular points. Okay, and this way, and this shaded region basically shows that yes, we can hyperparameter tune this particular line to some level. Okay, so and similarly, if I probably try to plot this with index underscore price, here also you'll be seeing an inverse manner, and from with respect to that, here also you'll be able to see this kind of line. Okay, so this was just an idea to give you. Every video I'll try to teach you something new, so I wanted to include this regression plot also, which will actually give you an idea. But again, you cannot do this for more than 2 features. You cannot basically create a 3D plot. It asks for only 2 features over here, X and Y. So with respect to that, you can definitely check it out. Okay. Now, since we have done our train test split, the next thing that we are going to do is that obviously standard scaling, right? So I'm going to write from sklearn dot. Now see, I am not remembering where the standard scaler fall, so I can go and search for it. Sklearn standard scaler. I'm actually, you do not remember everything, guys. So it is present in processing. Okay, right from sklearn dot pre-processing, I'm going to import standard scaler. Okay, standard scaler. I think that is only the spelling. Okay, standard scaler. Okay, perfect. So let me just go ahead and import processing. This usually happens when you are doing the coding, because I'm not seeing any materials as such right now, because whatever comes in my mind, I'm basically following the best methodologies as a developer, you know. So this will also help me to learn things better. So now what I'm actually going to do over here is that I'm going to create a scalar, and I'm going to basically say standard scalar, standard scalar, and I'm going to initialize it. Okay, then what we do, we write scalar dot fit underscore transform on my x underscore train data. Similarly, this will go in my x underscore train data, and similarly here you will be able to see x underscore test is equal to scalar dot fit underscore transform on our x test data. Okay, so this is my x train and x test. Perfect. We have got our x train now. Let's see, we don't have to do it for the y value. Now see, here you have got 2 values, right? And when we do fit underscore transform, it converts this into a 2-dimensional array. So initially I had a data frame, it gets converted into a 2-dimensional array. So this becomes my input, right? Now, the next step, what I'm actually going to do, I'm just going to write from sklearn dot linear model. Okay, I'm going to import something called as linear regression. Okay, and this will basically be my regression, where I'm specifically writing linear regression, and this I've got executed. Okay, then what I'm actually going to do, regression dot fit on my x train comma y train data. Okay, this is done. Now let me introduce you to something called as cross-val score also. Okay, now this cross-val score will also give you some good results. Okay, so let me just search for sklearn cross-val score. Okay, now as I said, every video I will try to teach you something new. Okay, now cross-val score is basically a cross-validation method. Okay, and this is where I really want to talk about cross-validation. And here all you have to do is that give your model, give your x train, y train, and this in turn will basically create a cross validation. Now what does this basically mean? Let's say I'm going to write over here. Okay, this is my regression, right? It has fitted to the x train and y train. Let's say I import cross validation. So if I say sklearn dot, let's see whether cross validation is falling. It falls in model selection, and I'm going to import cross val score. Okay, now inside this cross val score, what I'm going to say is that, okay, fine, this will be my cross val or cross, or let me say that this is my validation score. Okay, this in turn, first of all, we will give this cross val score over here. The data set that we are going to give, obviously when I press shift tab, I have to give my estimator. Estimator basically means my model. Okay, so here I have got my model, and then in the next parameter, if I probably go and see, I have to give my x and y value. Okay, so here obviously I will give my x train comma y underscore train. Perfect. The next parameter that I will probably give over here, if I see, there is something called as scoring. Okay, scoring parameter. Now in this particular case, let's see what should be the scoring parameter. Okay, So if you probably go and see over here, similar to cross validate, but only a single metric is used. So if I probably see a scoring parameter in that, let's say I'm just going to search for sklearn scoring metrics. Okay. Now inside this, if I go and check it out, how many different types of scoring parameter are there? So for classification, you have this many. For clustering, you have this many. For regression, you have this many. So let's say that I am just going to consider negative mean squared error. Okay. Negative mean squared error basically means I'm just going to get the mean squared error, but in a negative manner. Okay. So I'm just going to copy this and put it over here. Okay. This will be my scoring parameter. Okay. So here I'm just going to paste it. Perfect. Now this is done. Now my next parameter, what I'm actually going to do, if you go over here, the next parameter that is present, right, with respect to cross-val score is cross-validation. Now this is super important. If I say my CV is 5, okay, what does this basically mean? Or let's say I'm just going to make CV is equal to 3. Let's say if I have 1000 records, total records, okay. Now initially, let's say I made this as train, test, split, okay. Let's say in train I have 900 records, in test I have 100 records. This data I'm never going to use it, right? I will just be using this data. Now this data will only be used when we need to test our model with the new data. But further, to hyperparameter tune my model or to make my model better, I can split this train data into train and validation. Now when I split this data into train and validation, what will happen is that, let's say I will split this based on some mechanism. What mechanism? I will say, let's go ahead and take cross validation as 5. Now what will happen? If I divide 900 by 5, this basically indicates that what is the value that I'm going to get? 5 ones are 5 8s are 180, right? So this basically means in my first experiment, when I am taking my entire data set, the first 180 records will be my test data and remaining all will be my train data. Then in the second experiment, that is cross validation is equal to 2, the next 180 record will be my test data and remaining all will be the training data. Similarly, I'll go with respect to cross validation 5. The next, let me just do Control Z. The next 180 record will be my test and remaining all will be the train. Similarly, I'll go like this, and at the end of the day, we'll be able to there see at cross validation 5, the last 180 records will be my train test and remaining all will be my train data. Okay. Now, as you know that with this cross validation score, for every cross validation, we will be getting a MSC. From where did this MSC come? This came from this particular scoring parameter. Okay. So here we are going to use negative mean squared error. That basically means whatever MSC I'm getting, it will be in negative value. Okay. Negative value. So this is what we are going to do. And again, our target is that it should be, the more this value comes towards 0, the more better the specific model is. So here with the help of cross validation, I will be getting 5 different accuracies. This will be my MSC 1, MSC 2, MSC 3, MSC 4, MSC 5. And then I can probably take the average of all this and probably print it over here. Okay. So this is what we are going to do over here. So let me just go and show it to you. Right now I've just taken cross validation is equal to 5. That basically means I'm going to get 3 validation scores. Okay. So let me just execute it, and this has got executed. If I go and probably see my validation underscore score, here I'm getting 3 MSE values, mean squared error values. And now if I probably do the average of this, how do I find out the average of this? You can basically do np.mean, right? np.mean. So by this way, you'll be able to get the mean MSC. Okay. So this is basically my mean validation score by performing all my basically cross validation on this particular data set. Okay. But again, this is just to check or to do additional step of cross validation. So here, this is how you have to basically do the cross validation. Okay. With the model that we have created. But now let's go and do the prediction. So now I will do the prediction. Okay. Now, before we do the prediction, guys, I also want to make some assumptions. Okay. And these assumptions are super important. But before that, let me do the prediction. So here I will be using regression dot predict And here I'm just going to give my x underscore test data, and this will basically be my pred, y pred, right? So y underscore pred. Perfect. Now after this, all the things that are common, right? So first thing, I'm just going to go ahead with this entire code, that is performance metrics, and I'm just going to copy it over here. And similarly, I will go ahead and copy this, where I'll be finding the mean squared error and all. And here this is where I've actually printed. So this is my mean squared error with respect to the prediction data, and this is my mean absolute error with respect to the prediction data and RMSE. This is fine, right? Now let's start with some assumptions. But before this, let me also print the R square and adjusted R square, right? So here is my code. See guys, I'm just doing along with you. Please make sure that you also do it and you also practice. So this is my R square. And similarly, I will go and copy this, my print R square. And after that, I will also go ahead and print this specific value, right? So this is my adjusted R square, right? So here, this part also I'm going to print it. Now let's execute. Here you can see 75% I'm actually getting it as R square and 59% I'm getting as an adjusted R square. Okay. And obviously adjusted R square will be little less when compared to this. Okay. And but this is with respect to the test data to just see that how my model is performing well or not. Okay. But again, I just have small number of data points. So I'm able to get this. If we have more data points, if we have more dimensions at that point of time, we also have to check how the data is performing well or not. Now let's go ahead and let's learn something new. These are the assumptions. Like finally, I should be able to find out whether my model is performing well or not. And by seeing these assumptions, we can definitely come to a conclusion that my model will definitely perform well. So the first assumptions after we do the prediction, right? The first assumption is that I will just go ahead and plot my scatter plot. And I will say here, I'm just going to give my y test, comma y pred. Now, if I execute this here, you'll be able to see that they will be following some relationship here between the y test and y pred. If there is a linear relationship, that basically means your model has performed well. Okay. Now, the next thing that I am going to do is that with respect to residuals, let's go ahead and calculate the residuals or the errors between y test and y pred. If I take up this residuals, okay, residuals, here you will be able to see I will be getting these errors, right? These are my errors that I'm actually getting. Now, if I plot this residuals, with the help of dist plot, let's say, how do we write dist plot? SNS.dist plot. It is basically present in CBOM. And if I probably write residuals over here, and the kind of plot that I'm going to take is something called as KDE plot, that is kernel density estimator. And if I execute it here, you'll be able to get something called as a linear regression, normal distribution. So if this kind of curve is basically coming, that basically means yes, the model that you have created is good. Okay. And one final thing that we have to probably take with respect to assumptions is that let's create a scatter plot with respect to predictions and residuals. So if I probably create this plot with residuals and predictions, you'll also be able to see some observation. Okay, so what I'll write, I'll say plt.scatter with y underscore pred, comma residuals. Here you'll be able to see that follow any pattern. See, this data is uniformly distributed. Okay. Now you may be thinking, Krish, oh, the data is very less, no? Why you are saying it is uniformly distributed? First of all, let me remove this. Okay. Everything will make sense. Uniformly distributed basically means data is distributed everywhere. It does not follow any patterns as such. Here also you cannot see any patterns. When we'll be taking huge data set, in going forward, we'll be doing some projects which will be having many data points. You'll be seeing that this data sets points will be something like this. So this is uniformly distributed. It does not follow some patterns. If I say some patterns, it may follow something like this. Okay, it may follow this kind of pattern. If it follows this kind of pattern, that basically means something is wrong. Okay, but if it follows this uniform distribution, we can definitely come to a conclusion that there is no such problem as such. Okay. So yes, most of the thing we have covered in this. Now final thing is that obviously we need to compute the OLS, that is ordinary least square. So again, I'm going to copy this entire thing, copy the Y train and X train part and do the fit. And once I execute it, and if I see model.summary, now our main thing is basically to check whether are we getting the coefficients almost similar. So coefficient over here is 88.2728 and 116.2572. So are we getting that similar kind of coefficients? Finger crossed, right? So let's go ahead and print it. Where did I print it? So where is the code? Oh, I did not even print it. Amazing. Okay. So let's print the coefficient for my model. So here also, if I probably print regression dot coefficient, here you'll be able to see perfect 88.272 and 116.257. So yes, we have done a fabulous job, and with this formula also we are able to get this. Okay. Now in the next video, what we'll do is that we'll take up a problem statement, and let's say that if I have many features and all of these features have a concept of multicollinearity. Multicollinearity basically means that suppose if I have some input features, okay, I have feature 1, feature 2, feature 3, feature 4, okay, and with respect to R, if these two are correlated, 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 then it is fine. Okay. But what happens if these two features are correlated by 95% or 96%? Then what we can do is that since both this feature, since if this both the feature are correlated by this much percent, we can definitely say that almost both the feature are almost same. So we can remove one of the feature. But how to do this kind of elimination, we will try to have a look on to the next project that we are going to do. Okay. So yes, this was it from my side. I hope you like this particular session, and yes, I will see you all in the next session. Thank you.